Good morning. Sorry for the rough start, but hopefully we'll make up for that. What we do plan on talking about today is the multi-criteria decision analysis models and how this adds to our capability. So this is really the kind of the payoff point to doing all this work. Lots of background, lots of information, and now you're trying to roll all this information up in and make it makes sense to decision makers. And this is we're trying to create models that not only have data background and the things we normally look at with things we look at with money. And so just quickly, I want to review the models that I put in here. So the economic model, the first one, just had an investment, and so this is kind of the money and energy model right here. And don't worry about that. Don't worry about what you're seeing here yet. We'll go through this step by step on how to create all this. The second model we did is we went and did the investment. So we had money and energy, but we broke that down into two different ways of looking at that. So we look at either as the total or an equivalent annual. So basically, lump sum or payments as two different options. After that, I wanted to take away and add in, site energy over here on the side, so that we knew we can see the difference when we break it out to site and source energy when we add the weightings in for those different models. And then finally, this is finally kind of looking at this weighting here and looking at all those with just bringing in the purchase electricity, or giving us a look into what it would be like if we had trying to put in a way to talk about energy security. So with those things, we're going to go back and kind of start from scratch with ours and kind of build those models. So what we have, like I said, one of the first things that we do is, we've gone through, generated our loads, looked at our installations, and we've gone to and we've looked at the summary report. And if you remember, in our summary report, just to review, we had our baseline case, which is the case that we calibrate to. After that, we look at the base case, which is our business as usual projected case as we look forward. And then we looked at a better case, so we kind of drove some of the energy models down to to a different point in that cost curve, more around that. If we were thinking about kind of closer to that 2 or 3 point, so kind of the economical, and then maybe pushing it beyond that. And then the best case, we were pushing up to beyond and pushing into things that were where the cost of the energy didn't necessarily pay for implementing the case, that there was other reasons why we were pushing that. So then we took the best case and we did a cogen model with it, realizing that there is ways of getting biomass and in this case it's natural gas cogen. So just looking at how that improves the model. And then we did our best case with a 30% source reduction by adding solar. And if you remember back from the installation piece, when Matt just put solar on by itself, it didn't select it, right? So we had to force the constraint. So just using the money and the cost of the solar to offset the electricity didn't pay for those benefits. So Matt had to take those source reductions and say, okay, we want a 30% source reduction, and so let's find the most cost-effective option to get that source reduction. That's how we determined. That's how how that optimization was constrained or pushed to those results. So that's a little bit of background. So we have to kind of remember that. And it's been a few weeks since we've talked about that, and so we got to remember what we're trying to accomplish as we were doing that. So now as we go forward in our current model, we want to make some sense of this. And so how do we start justifying what direction we want to go with this? And so, like I said, we have this thing called a multi-criteria decision analysis model. And this rolls up the data and puts the constraints and puts in different influences on this. So the first thing we want to do is create a new MCDA model. We do that by hitting this, and then we want to title this. And what I wanted to do at first is just put this in, just looking at energy and money, kind of what we typically do. Yep, do that. Okay, so it creates a model. We're then going to go in and go inside and view this. And this is the steps we'll want to take. So just, I think by the time we've generated our third and fourth case, that this will become second nature to you. So what we've done is we now have our economic model here, and there's nothing here, no constraints, no metrics, or anything. And when I clicked on it off the criteria tree, it automatically tried to take this economic and add some metrics to it. But what we want to do is we want to kind of split this between money. So we want to look at, and I want to look at what the total investment is. Investment, yep. And then I just want to look at, and I want to stay right here. It's this economic is selected right here. So this is going to be end up being a tree. So we've got the base of it, and we're going to add another constraint to that, and we're going to call that total site energy. Okay. Now it automatically does a split just by the number of these that are there. Just equally divides those into those two groups, and that's fine. Because later on, after we add the metrics to that, we're going to come back and we're going to play with the sensitivity of those metrics. And so we're going to go in here. Next, we have to go into each of these, and we have to create the metric. And what all a metric is a way to put a score. So you think what we would do if we were taking a test and we were saying that 100% is good, or a 1, and we're saying that 0 is bad. So think of it that way. All we're trying to do is score between 0 and 1, or 100% and 0%. But we have to tell it how we want that to score it. So fortunately, there's a lot of built-in pieces to that. So what I did is I clicked metric. You can also make them constants. There's a way of doing a lot of custom stuff. We're not going to look at that today. We're going to look at kind of the typical way and look at a lot of the custom stuff that's already here. And so, like I said, this is going to be this was the total, our total investment in dollars. Now, remember what this is made up of, this total investment in dollars? It's made up of the building investment plus the cluster investment, right? And so that's our total. We want to click on that, which gives it the name and the unit, and what it does is it drops that down here. So we want to say our metric is in dollars, and now we see that down here, so it's automatically put a scale on here. And now we have to put kind of value functions. So we're going to say what percentage or what dollars is good and what dollars is bad. And we do get help with that, fortunately. One of the things, since we have selected total investment, we look right up here at our metric value right here, so we know our baseline is 0. And so why is our baseline 0 again? That's a question. Go ahead. Somebody can answer. Everybody's on mute. I got it. Okay, so baseline is 0 because our baseline, we're not investing in anything. Now our base case had a business as usual. We had a $52 million investment in the base case. This is money we were going to spend anyway, right? And then as we added efficiencies, so beyond our baseline, we needed to spend $52 million. We could go back and look at that. That was all built up from our buildings and our installation and clusters. These values were, and like I said, we could go back and you can go back and review those and see where all this came from. But today we're just looking at these rolled up results. In our better case was we added more building energy efficiency measures in, and in our best case we added quite a bit more building efficiency measures in there. Now our best case with cogen, and remember we added the cogen to that cluster that already existed. I don't know if you recall that. So and then we added, in the best case we added solar. Okay, so in this case we want to decide what is our best value. So I wanted to start with saying, well, if we spent nothing, that seems to be always a good place to start. So if we want to spend nothing, we hit that, and our value function is 0. What we're going to start though is with a linear minimization. So these are our templates, and this just kind of builds all this in. So we can have several different types of templates. So that'd be a maximization. So that would be if we maximize something, we would give it a score of 1, and if we minimize, it would be a score of 0. Well, in this case, what we're trying to do is we're trying to minimize our expense, right? So we're giving a higher score if we spend less. And so in this case, if we're saying that the metric value is 0 if we want this value function of 1, and if that metric value is like 180 million, so we pick something greater than what we're as a bad function. So what we see here is if we spend nothing, we get a high score. If we spend 180 million, we get a low score, right? Now, if we look up here, as soon as we put those metric values in, we can see what our scores are. So our baseline spending 0 gave us a value function of 1, but a score of 0.5. Now, the 0.5 is telling us that 50% of it is based on money. The other 50% is based on something else. So it gives us the score here of what this would be, giving this as our metric between those. And so we can see that we go from, like I said, a high score of spending nothing and a low score of spending a lot of money, right? Okay, so we're going to leave this for now, and we're going to come back and tweak that. But we also need to do the same thing on the energy side. So it's the same process. We come down here, we hit our metric. Now our metric is going to be, we're going to start just with site energy. Okay, and then we're going to, right down here, you'll see our metric value has no units and our name, and so all we do is hit that, boom, and it gives us brings that stuff down here. And on energy, do we want to maximize it, minimize it, or leave it the same? What do we want to do on energy for a template? We typically want to minimize energy and minimize dollars, right? So that's what we're trying to do, and we're trying to optimize those minimizations. So as we look at the total site energy, we see that we have our baseline has, and these are in megawatt hours, and this is we have 103,000 megawatt hours, and so this is energy, not peak load. So don't think of that. And our best case with source reduction has about 77. So we want to sit there and put in some range on that, and we did a linear minimization on here as well. So for we want to say for our value function, if we get something lower than this, we're feeling pretty happy. So let's put in 50,000. And basically that, and then for our bad function, we give it the lowest score, and we want to put that somewhere around, above our base case. So we can put in, 150. You could put 136,000 in, but we'll just put in something in that range. And then what we see is, if we're at 50,000 megawatt hours, that gives us a good score. So just have to think about a teacher, and you're scoring your test here. And then if you had a bad scores, if you get 150,000 or more, so something even worse than our base case, right? So our base case is supposedly building business as usual, and if we build worse than business as usual, that's really bad. So we're giving that a very low score, right? Now we look up here, we see our value functions here. So our baseline came in at a 0.46, and our best case with cogen came in at 5.1, and our best case came in at 6.3, and our best case with solar reduction came in at a 7.34. So what's the first thing that you see that kind of might bother your eye? Anybody? Can anybody see something? I'm circling the area that I'm looking at. There's something here that bothers your eye? Remember, this is total site energy.
The value has gone back up.
Okay, so we see the scores coming as our reductions are coming down. We see that, and the trend seems good. 46, 13, 46, right? So it pops up with the base case. It goes up with the base case because we have more square footage. It's not that we're building worse. We're building better, but our new building's better, but we also have more of them. So we're actually using more energy in this case. And then we see the better case, hey, it comes down, and our score gets, looks like about the same as the baseline. Our best case drops down, score goes up. But then all of a sudden we get to this best case with cogen, and we're going, well, why is that cogen causing that to be worse than our best case? Does that make sense? Why'd the energy go up? This is why, well, if you do talk about cogen, why people don't like to talk just about site energy, because if you are producing your energy and you're using a fuel on site to produce it, even if it's more efficient, you're still using more on-site energy. So that's what happens with cogen, right? So now we reduce the energy further with the solar reduction, and the score goes back up. So when you're looking just at site energy, this cogen doesn't sit there and doesn't necessarily score well, right? Because it uses more energy on site. And so we're going to look at that in a bit when we develop another case, and you'll see why we might want to look a little bit further than just site energy. We also might want to see why we want to look just a little bit further than just total investment. Okay, so we end up with this. Now, this is what we're seeing. The first thing what we see, and what we see is this is the MCDA score. Now the total score, and this is also set in its rank, right? So at this point, we see that the baseline, doing nothing, comes up with the highest score. Well, that's not really what we're doing, right? So do we really want to compare, base our other options on the baseline? Is that what once again, is that what we're trying to do? We're trying to we're trying to compare this against the base case. That's why it's important to have the base case, right? Because you see in the baseline, we have less buildings, we use less energy, we spend less money. So, but that's not what we're doing. What we're doing is the base case. So we are building more buildings. We are destructing some. We're building some of those, and this is business as usual. This is what we would do, looking out at the end of our plan. And so this is what we're really comparing these alternatives against. But it's always good to know how it compares. How does all that look compared to the baseline? We always want to look back there. But when we're kind of looking at our judgment, what we want to do, we want to look at our base case, and that's why the base case is so important, right? So at this point, with time and money, we see that the better case is sitting really in the top spot, right? Then the best case. And we see this because just with time and money, we spend more on the building that doesn't necessarily pay back. But it's close. It's close now that we've compared this. But let's just remind ourselves how those scores looked again. So let's go back just to money. So we click on the money one here, right? And we go, oh, look at that. Oh, I remember now, right? The baseline, base case, yeah. We spend more, it doesn't like it. We spend less, it does like it, right? So we can see that. And we go, all right, well, okay, let's add that in with how's the energy thing look? Well, all right, the baseline's here. The base case has even a worse score, right? Remember, the longer the green bar, the better. And we see at this best case with solar, if it was just energy, right, we'd be looking at best case with solar or best case, right? These are the two cases we'd be looking at if it was just energy. And if it was just money, we would do nothing, right? Or we would do the base case, right? But this gives us the combination up here, right? And so now we can see how these score together. But then somebody says, well, I know, but we're just weighting those, 50-50. I may think money is more important, or I may think energy is more important. So what's really cool about this is if you click on one of these, let's say the total site energy, so we can just think in terms of the energy, what we can look at is this sensitivity analysis. And this is where we get what some of us call the pickup sticks diagram, and that's this, right? And it'll make sense in a minute, so don't get totally blown away by that. But right now, this is sitting at 50-50, right? On the energy side, we're looking at a weight of 50, and if we go to the far right, what we're saying is energy is more important. Now, as I move this way, look what's happening. Well, a lot of things. I'm going to stop right here at this cross, right there, right. So one of the things we see is that the weighting on the sites come up and the weighting on the investments come way down. So for the people who only want to think energy, we would go to 100% energy, and lo and behold, it kind of looks like the solution of what we just showed for the energy. And then if we go completely to the other end, and this is changing orders as we're going as well. I don't know if you know, it's not staying. This is staying in rank, total score rank order. These names are popping around. But if all we're cared about is money, then it goes to the money solution, right? So what we look at is we see baseline here is the dark blue, and so we see it has the best score at 1, and it has a lower score here. As it goes, as you bring in energy is more important than money, right? So this is kind of the path of the baseline. Now the base case is green, so the base case is always sitting. We're going to call it on top because we're not really comparing it to this. So the base case sits on top until it hits, boom, it hits this red line, which is the better case. Okay, so what's going on right there? So let's sit there and look at that. So the base case is sitting here on top, and the better case is sitting second. If we're looking at about a 60-40 weight of money at 60 and energy at 40, but as we creep up closer to the real 40, all of a sudden, boom, there we had that flip. Did you see that flip? Now the base case went into, we'll call it second place, and the better case popped up. So if we're thinking 40% energy and 60% money, so if we weighted it that way, then currently the weighting order of our models would go better case, base case, best case with cogen, best case with solar, right? Remember, we're thinking pretty heavily on money here. Can we predict where these are going to flip? Well, we could just move this until they flip, or we can start seeing that. So this is purple, this base case with solar, right here, 20% reduction, and that's right here. So we see this purple case coming through, and it's lying underneath all the other cases when it's all related to money, right? As we get more and more weighting of energy, it crosses over, right there. Now there's the orange case. The orange case is that best case with cogen right here. That's that orange case right there, and it kind of continues on like that. So we see that the purple case finally crosses over. It's like, oh, okay, if we weight it here, then it's a little bit better than the. So let's do that. So let's move it. Boom. Okay, they're changed right there. As we get close to that 50-50 thing, we see that's about where that best case and best case with solar, best case with cogen kind of flip right there. You see them crossing over right here, right? So if you follow, but you can do that with all these models, right? So if you follow any of these models, so here's our best case, the light blue, and you can see it rides pretty high up. And, as you go all the way to the energy side, you can see that here's the best case, and the best case with solar rides up here. And like I said, this is just an energy look at it. This is just a money look at it, and this is everything in between. So what we can do then is look at these percents and say, well, and you do this as a group. This is where having your goals, right? This is where it's really important to have your goals and really important to have your stakeholders, because you're not trying to manipulate this. You're trying to get it to where everybody is putting their input in, and you're trying to come up with a decision. So if we're doing it just on a investment in energy, so you got your people there who are watching the dollars, and you got the people who are watching the energy, and we're trying to make a decision out of that, or a compromise, right? And so we want to look at the data and see what the data tells us. And so if we do come to this 60%, say 60% energy, 40%, because we have some ideas that we'd like to do better on our energy, and if let's say we selected that, then this is what the models would line up as, right? So we would see that our best case would sit there, and our best case with solar would lie right under it, fairly close, given our propensity to make sure we're keeping an eye to the money, and or an eye to the energy, excuse me. All right, so if nobody has any druthers on that, we're going to go ahead and change this. So how do we change that? That's kind of our experimental look at it. We get to play with those numbers, but we don't really change it till we come here, and we come down here and we change our weights. Now this is our official weight. So currently that's what it's at. So let's say we went to 40, 60. Now we see that we've changed those weights. Now this officially changes it back in the models all through here. So it's not just at this point, it's not just our looking at a sensitivity analysis of it, right? But we got to look at that. And so we look at this and we're going, okay, well, that's interesting. Well, let's now go on and see what happens if and not everybody has to have the same models. You can have different models for different groups. So you can have a model for just the energy and the energy security people. You can have a model for the environmental and sustainability, or combined models, and then you can even rank the models in the end, right? And we're going to see that as well. So what we're going to do as we look at our experiment, we're going to close, and of course we want to save, because I've done this plenty of times myself, where I've clicked on this close and I said, oh, I don't want to make any changes, but then I end up not saving anything, and it's really a pain. So I'm not saying hit save every time, but I also am saying that you better make sure, and sometimes it's easier to hit save than it is to lose it and start over. Just a word of warning. So we're going to go to our second model, and we're going to call this model economic with total and annualized. And so what am I trying to do? I'm trying to add in a different look. With total and so we're going to say this is okay. So same thing. So if you notice, there's no copy. So we do have to go into this and set it up each time. And it's not, we're doing it, it seems like it's a lot of work because we're just doing boom, 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 adding 4 models in. But it's not that, I'm just going to say it's not that bad to do it. And in this case, it's good exercise for us to learn. So this one, what I like to do is add in our kind of build the tree first and then define the metrics. So the first part of that tree is the investment. Investment. I want to spell it right. And then this is selected, so I want to hit Add New. And this is going to be our total site energy again. Okay. Now, there's our investment and our total site energy, but we did change the weight on that, so we do want to go ahead and change that now because we want to be able to compare it back to the other one, so we want to have the same weight on it as our first model. We don't have to, but that's what I want to do. And then we're going to, now watch this. So this one is selected. Do you see the highlight here? I'm selecting investment, right? And then when I hit Add New, it splits. It splits and puts it off of this one. Okay, so this is selected, and I hit Add New. It puts a branch off of this. Okay, so I'm gonna do it again, and I'm gonna call this one Total Equivalent Annual Cost. Okay, and right now it's set at 2020, and we can look at that in a minute as well. All right, so let's go back and check our metrics and for our investment. I'm sorry, we want to start that with our site energy because we actually want to go down here and build it at this bottom end here. So let's go back and set that first. And who remembers what the numbers were? I'm trying to get somebody thinking ahead as we're moving in that direction. So we did, on the energy, we chose total site energy, right? And that was from that 103 to 76. And we wanted to update the name, and then we wanted to put a minimization template in place, and we're just trying to replicate what we did. And we had for our 1 value, we had 50,000. All right, and on our 0 value, we had 150,000. All right, so that replicates what we did a moment ago. And we can go back to our tree, and what we see right now, of course, these guys are all zeros, so what we're seeing is our energy pick. Look at this once again. So it shows this because we've selected it. And by the way, down below here, you do have your framing goals that came in from that front sheet. So this is what we had, that reduced 30%, and we had some other targets that these, if we kept these up to date, these would be here and this would be reflected, and then we would then just kind of we'd be able to build the models knowing those goals. That's why I said it's very important to have and understand those goals. And then we also have all this data here to use in these models how we choose. And at some point we can make combinations of stuff. We can do math on this stuff and other different things. But like I said, we're going to just kind of look at what we have today, kind of what I call a more straightforward approach. So we just set our energy back up. Now we got to go in and look at what our investment does. Now if we click on this, once again, this just gives us our weights. Gives us our 50-50 to give us our 20-20 weight, right? It's split at 40 evenly. And then we're going to go to our total investment, which should look a lot like what we had done before. Okay, so we're going to use the metric. We're going to select that metric, which was total investment, update the units, and then come down here and put our minimize, do a linear minimization. We're going to see what our low value said if we did 180 million. That was bad, right? 180 million. And if we did 0, that was good, right? And we looked at and we see what our scores come out to be, all right? So we're going to take that for a minute there and look at that. Now we're going to add this new one in. Now this new one is new to us. All we're doing here is looking at the total equivalent annual cost. So we're kind of doing, this is kind of the car dealer thing, right? It's kind of the car costs $30,000, but it's only $218 a month on a 50-year loan. You know those car dealers are. They just try to put it in terms of the loan. But we want to see what happens if we do look at this in terms of, because most of the time what happens is that we look at that. So we're looking at dollars per year, and most of the time what we're looking at is something where we don't have the budget to come up with 160 million. Even we don't even have the budget to come up with 50 million. So we really have to look at coming up with the funding of this over time anyway. But we do want to see how that looks and how it compares, right? That's just. So in this case, we are also trying to minimize our payments as well. We want to minimize our investment. We also want to minimize our payments. So we go to a linear minimization on this as well. And a good thing would be to have low payments, right? So in this particular case, when we look at our payments, we have a range here of $8 million in dollars a year in our baseline. This is what we were paying a year, right? $8,637,000. This is what we were paying. Our base case, so in other words, we built all these buildings. If we did nothing else, our utility bills and then in an investment piece would go up to this $13 million. And if you go back and look at this baseline, remember there was a 0 on the investment for capital. So this really is our it's kind of the utilities with the old building structures. And this we did have some capital investment, but we also have the utilities in here as well. And so that's the same with all of these. So we want to set up a scoring system here that allows us this. So if we could actually, if we could keep the payments down to, we could get it down to $8 million a year, that would actually be good, because that would be lower than what we were paying in the baseline, right? So that'd be, to me, that'd be a really good thing to do, is get this lower than what we were doing previously, even before we started this building. That would be great if we could do that, right? All right, and then it would be a bad score if we went and had, in this case, I'm seeing something around 13 million, like our base case. If we go to our base case and we get something around this 13, 14 million thing, so let's just do 13, because we really do want to do better than that. So what we're looking at is if we can keep our payments less than what we started out with before we even started building, and if we can keep them no more than what we did if we did business as usual and built all these additional buildings, then that would be that's how I would, I think would be a good weighting of this. And you can see how the scores come out already, right? We can see that our baseline is comes up with a score because it's going to have low payments, close to that minimal goal, and we can see how that scores in. So our base case pretty much has the worst score, and some of these that are have reduced payments have a little bit higher score, right? So now we want to look at this in aggregate. So let's go back to our tree, and this is how our total equivalent annual cost looks in isolation. This is how the investment looks in isolation. This is how our site energy looks in isolation, and we see our splits here. And we can then see how our total scores for the models look. So in this situation, we're looking here, the baseline is still at the top, but that's really not what we're comparing against, right? And then we look down here at the bottom, and we see that the base case is the worst. So doing business as usual is our worst decision, given this structure right here. And this is not that wild at this moment. So what I mean is, we say energy is important, and we say, hey, I still want to look at the big gulp, how much I'm going to take, what the total bill is, but I also want to make sure it's in line with what we need to come up with from our annual budgets. And we look at this, so it's not way out of whack for what what we kind of typically do, and we see that our base case is the worst thing to do, right? And so we're starting to see that these other cases are better. Now, we see that this best case with source reduction, pretty much that's pretty much a tie. You starting to get down here in significant digits, 0.532, 532. So at this point, we could look at that sensitivity on energy again, and we can see that those are really, really close right there. So that purple and that blue line are sitting right on. That's actually a crossing point for those two cases. You can see right here. So there's our blue, there's our purple, and if we had more on, if we just weighted a little bit more on energy, then our base case with source reduction would be a clearer winner. And if we come back to this side, we say, hey, you know what? There's too much risk. I want to think more about the money. If I came back this way, I could come back down to. Looks like I could come back down to about 50-some% in here, and this best case would be a clear. Would be beating out this. So if I was a little bit more conservative on the money side, then it would pop back. And if I was more aggressive on the energy side, then you can see it gets further and further apart here as it moves that way. But what changed, big picture, what changed is, so we look at this by adding in this total equivalent annual cost. So what changed? So let's close this model and save it. And we're going to show you the first time you're going to see this is this comparison of models. And so we move forward here. We're going to come back. But what changed here? And what we look for when we compare all these models against each other like this is a path. What I'm looking for is a path. And so one of the first things I see in this path is, and we're kind of, like I said, we're kind of negating this part here up here, but one of the things that I see is if I do nothing, I mean absolutely nothing, that's the least amount of risk, and depending on what we're doing, that would be kind of a way to go. But that's not what we're doing. So our business as usual, and what our plan is to do this base case. And what I see here is that in both of those models, the energy and investment with just the lump sum investment cost, and with the investment in payments, the lump sum and the payments, that lies on the bottom. So that's always the worst thing. Always the worst thing to do is, in this case, is to do our business as usual, by our data, given what we've seen so far, right? What we do see is that model 2, right here, is this best case, is sitting here at the top of, it's sitting here at the top right here. So once you get rid of the base line, if you look at this best case, I got to get this right. Okay, there's our best case. So in our economic model, it was ranked number 2, and in our economic with total and annualized, it was ranked number 3, and our solar popped up to 2. So look at that. So if we look at it annualized, this is just a money look, the same percentage, right? It's the same percentage split between energy and investment, right? But if we just look at how we deal with our money, that the solar popped up to a better option in the annualized with the payment, I'll call it the payment case, right? It actually came in as the second best option. And I would not have guessed that, right? I wouldn't have guessed that. And I didn't even try to manipulate it there. I mean, that was surprising to me. Just by changing how we deal with the money, and look at that model popped up right there. So this is the rank order by the first model, 1, 2, 3, 4, 5, 6, given this. And this is the rank order 1, 3, 2, 5, 4, 6, given that second model. And we can see the span on that. So we see that adding that payment piece gave a little bit of spread between each of these models. And then of course you got this score here, which kind of gives the overall score. So you're really kind of looking at this point, what you're really looking at is, do you want to do best case? Our best case was solar with some PV to reduce 30% source reduction. So that's what you're really looking at this point. But there's a couple tweaks here. So let's go ahead and go. Where's my back button? Here we go. I don't want to lose anything. That's how you compare those models, right? I don't know. I thought it was interesting. And maybe it's a Monday morning on June 13th. But there's one little thing in here that we looked at when we put together this investment piece here, okay? And what we did is we said 0 gives us our best score. Well, in reality, we're not really looking at 0 as what we're trying to do, right? What we're really thinking is that we really need to compare that against our base case, okay? So instead of 0, I think that should be closer to this base money right here, $53 million, because that's what we're going to spend anyway. So put that in, and what it does is it gets this, it gives a different ranking here. Now, anything below this value keeps that top score, all right? Does that make sense? So if you 53 or less, you can only get a top score of 1. Okay, so that's how you look at that. So even though we moved it up, okay, and I think I only have to do that in that total investment piece. Now, we see a change here. Still the baseline, better case, best case. I think, it changed. This better case and best case now are sitting right here together, okay? And this best case with solar is sitting back here a little bit. So it actually moved to a 4th place, where before it was 3rd place. You remember that? Best case, these two kind of swapped. This best case dropped even further. You'd have to remember that from a moment ago. All right, so we're going to go ahead and keep that. We're going to put that in the other model as well. I'm not trying to manipulate this. We're just trying to make it reflect more what we really think could or should happen. So we said this was what, 53 million? Boom. Okay, yep, so that changed that. And we go back there, look at our criteria tree, and now that's what I expect there. But overall, our rank went from best case was solar, best case with cogen, better case. So this one, when we went to payments and we changed this a little bit, there's been a swap up here in these models. Okay, so a minute ago, this was sitting at the top, this best case solar with a source reduction. And this better case was a little bit higher. Okay, so let's close that. Let's make sure we save it. Okay, let's look at those quickly just to see if those ranks changed. So that best case was, before it was, 2 and 3? That best case with solar was 3 and 2, I believe. So you can see how this is all kind of shifted around. So now if we look at this, we can see that this better case has got a fairly wide, I don't want to say error bar, but the deviation between those two models went fairly wide on this better case. So it went from 2 to 5 instead of 2 to 3. Okay, so that changed that quite a bit. This went 3 to 4. And the best case is now sitting up here 2 to 3. So if you're looking at the rank models now with the numbers that we put in there, we're really kind of looking now at the difference between the best case and a better case between our two options, and depending on how we want to spend the money there. But it really says that the best case is just sitting here right on top. Okay. Just that slight little change in the metric value, changed that, and we see that this average rank score changed. So its highest rank now on the best case was 2, lowest 3, is an average rank of 2.5. Base case didn't move. That's important. It's still the worst thing to do. So doing business as usual, looking at all this is the worst thing to do. Okay. All right. So that gives you all this, but everybody's probably saying to me at this point, well, you didn't really give some of those models a fair chance because you didn't take into account that source energy. And so what we want to do is say, okay, well, let's do that. I mean, that's one of the things we wanted to look at, is we wanted to look at site and source when we put this together, right? So let's create a model that takes that into account, and let's see what we get. Okay, so we've got, this is our third one, and this is going to be economic with site and source energy. That's not easy. Okay. All right. So we're going to view that model. I want to create that tree first. It starts looking more interesting as we put together this tree, but we're just building it slowly so we can kind of see how the results change and why we're doing these certain things. So we're seeing this as we go along. So we want to start with our investment, and the other one is energy. Okay, so and we wanted to do we want to hold the sensitivity the same, or how we want to weight between investment and energy. We want to hold those the same between all the models. Now let's go to the investment and add our branches there, and we got our total investment. Total. And total annual or annualized. Okay, so we're going to keep those weights, and then we're going to go to our energy. All I did is select the energy, add new, and we're going to go to site, and now we're going to make our one. Okay, come back here. Now we're going to make our one change that's going to be different. Is we're going to look at the source energy this time. Okay. And so we see we've got a 40-60 with a 20-20 and a 30-30 split between these branches out here. And we're just going to go start at the top. And we're just going to pretty much go through those just as we have done. And so quickly we should be able to do metric, and we're looking at total investment. Boom, we're going to update the name, a linear minimization. And for our bottom score on this one, what was that again? All right, 180 million. And then our good score was going to be 50 million. So we want to do. It's really bad if we do worse than this, and we do. It's good if we do around our base case or better. Okay, and that is all we have to do for that. Right? Go to our annualized metric value, and we're looking for that total equivalent annual cost. Boom. We want to update that metric, dollars per year. And now we want to talk about, we want to minimize our payments as well. So we said it was a very bad thing if we spent so if we spent, yeah, 13 million, if we spent that would be bad. Dollars per year, 13 million, right? 1, 2, 3, 1, 2, 3. You hate to put the wrong metric in there and change everything because you put the wrong metric from one model to the other. 3, 1, 2, 3. All right. Okay, so that's pretty much, that's what we had in that, what we added in Model 2. We added that payment weight. Okay, and we want to go to our total site. And this is going to be total site energy. And in this one, we had, back to our tree, total site energy. What was it? Okay, I remember. So megawatts per hour, update that. We want to minimize that as well. We said if 150,000 would have been bad, right? 150,000, something greater than this base case. And we said if we did 50,000, that would be really good. That would even be better than this. That's megawatt hours, just so we make sure we remember our units for those values. Okay, so we went to 150,000 megawatt hours or 50,000 megawatt hours for total site energy, which is right here. So I'm just looking at this. We can see the scores here. Our base case has a low score, and our best case with solar at 30% reduction has our best score in this particular case. All right, so the only thing we haven't done is this total source. So now we want to go to the total source, and we want to add that in. So that's new for us. So it's a metric, and the metric value is going to be total source energy in megawatt hours. We're going to update those units. We do want to minimize this as well. We seem to be wanting to minimize everything, money and energy. We haven't put in things like comfort and tried to base comfort on different things, but we could do those types of options as well if we were able to dive into that. You can. What my point is that you can quantify non-quantifiable features using this piece of the tool. Okay, that's what I'm trying to allude to. And that you can actually add that in there and put the weight. So somebody has let's just say has a high value to comfort, and we were able to put comfort in here. We would do that with temperature. We could then we could actually look at that and try to weight that and stick that in the model as well. Okay, that's an aside for what we're doing here, but just wanted to point that out. All right, for our source energy, we see that we have 278,000 or 279,000 here, right? Is our base case, and our lowest source energy here is 146. So if we did, so our bad value would be something greater than this base case. So we'll make that, let's say, 300,000. All right. Then our best number here is 146. So if we could do a little bit better than this, that would be great. So let's just say 140. And that will give us our best score. Now when we go back to our criteria tree and we see our site energy piece, our total source energy piece, our base case score is one of the lowest, and our best scores are up here with our best case with cogen and our best case with our 30% source reduction. That's probably a pretty good case because we put in a 30% source reduction, and we achieved that, and that's we can see it got it. It did better than the best case with cogen in that case, given this metric. All right. As always, if we go into these and we look at, let's say, this site source we want to see, we can look at the sensitivity between any of these things. So if we wanted to come in here and we wanted to look at the sensitivity between total equivalent and total investment, we would come here and we'd look at that. And some of these are pretty flat. You don't learn a whole lot. But we just see that our base case here is decidedly the worst thing to do. Sitting here, it's under all the models. And our blue case is our baseline. We're not really looking at that. And so what we're looking at here is this cluster of models all through here, and then how they fan out, right? And we can see that, right? So I'm just saying, the point is that we can look at the sensitivity of anything in here, not just at this level or this level. So we can go in here and look at anything. So let's go look at this source and site sensitivity. Let's just see what we see if we do that. And what I see when I look at this is baseline is sitting up here, and it crosses in. So when we weight it 50-50 between site and source, where final weights are 30-30, it's pretty flat through here, the baseline. And our base case is pretty flat sitting down here. And then we see the other models shifting around here. And then we see finally right out here, we see this orange model, which is the best case with cogen, popping above even our baseline. So in source energy, we can even see that in this case, it's even popping above. It's even popping above our baseline. So that's kind of interesting. So what that says to me is we're using less base energy, source energy than when we had less buildings, and that's kind of interesting. What I saw right here, but that's pretty subtle. We wouldn't really have a reason to shift this. So let's just look at what the model results are, and what we see here. Now remember, this accounts for all the money, all the energy given these weights. This is how the models line up. So you can see that the best case with cogen is the best option at this point, with the solar coming in right behind that. And then we have our best case and better case. And then finally, that base case, once again, trailing in this model in 6th place. So we just can't, this base case is still not what we'd want to do. And we're sitting there kind of fighting between kind of these cases out here, the best case with solar, or best case with cogen, now that we've added in our source energy as a criteria. So this changes what happens on site. So what we're seeing here is that, yes, we're going to use more site energy. We're going to produce our energy on site, which also it goes to speaking a little bit about our energy security, which we haven't talked about. But we see here, we're kind of looking at, what should we do? Just do the buildings? Just do the buildings with putting PV in, or actually trying to go and put cogen in? So that's kind of what we're fighting with right now, or kind of in these areas. So let's go look at one more model. I think that's all we have time for anyway. Let's make sure we save that. I'd hate to lose that, putting all that information in. And let's go do, let's see if we can talk about how we can look at that energy security piece. So we want to create a new model. We're going to call this energy security. And create that one. And at this point, I'd love to be able to copy that, even myself, but the answer is no. So we're going to go in here, and we're going to start at our top of our tree. We're going to start adding branches. So we're going to come in here, and the first thing we want to make sure we still account for is our investment. We also want to come down here and talk about our energy. And then this one we're going to call, it's kind of our energy security, and we're going to base that on by our reduction of purchased site electric. Our purchased site electric. So I'm going to kind of relate our energy security to what we purchase in our off-site electricity. Okay, and we're going to look at this. And right now, I'm just going to leave the splits between these at it's a third each, and then I'm going to add in our branches that we've had here for okay, and I'm going to add in our total site. And in our total source. And that I'm going to leave alone. All right. So what we're really doing at this point is we're kind of replicating everything that we're going to replicate everything that we've done for this section. Okay, and then we're going to add in this piece here. All right, is our fourth model. So we pretty much have know what we're going to do for these models. So metric, total investment, units, minimize, and our investment was at 53 million to 160. So our low value is going to be that that arbitrarily 180 million, and then here we're going to make it to 53 million. Okay, and that's scores. And let's go back, and let's do our total equivalent. Okay, minimization template. And our values here were, if we go back and remember here, we're trying to, we'd like to reduce our payments below what we did in the baseline, but we really don't want to go over what we would have been. So let's, so our worst case is at 13 million, right? Dollars per year, 1, 2, 3, 1, 2, 3, and 8 million. And 13 million and 8 million. Okay. So that's our total equivalent annual cost. Okay, go down to our total site. So like I said before, once you've done this and redone this and done it again, it should be you should see the repetition, and it's not that difficult to do this. Select the metric, and this is our total site energy. We want to minimize that as well. And we don't want to get that any worse than 150,000 megawatt hours. And we'd like to be better than 50,000 megawatt hours. Right? 150, 50. All right, that looks good. And now we want to do our total source. Metric. Total source. Units. And we can see our values here. And if you recall, we went over 300,000. That was that probably isn't a good. So we want to minimize it. Our bad value is about 300,000. And our good value is about 150,000. 140,000, I think, is what we chose before. All right, so that's our source energy. And at this point, we still don't have score because we don't have energy security, a total score, but we start seeing the same rank order of these sub-criterias. And let's go to our energy security. And we're calling that energy security is if we have to buy less electricity off-site, then we're less vulnerable to purchase electric site disruptions, right? So that's kind of our idea for this. So we're going to look at the electricity site right here, and if we can find things that replace that site electricity and make it lower, then we feel, like I said, we have less disruptions to that. With that, we're in megawatt hours again, and we see that ideally we'd like to go to 0, right? So we're going to do a minimization again, trying to minimize this as well. Ideally, we'd want to go to 0, but we don't want to do any worse than our base case, which is sitting right here at about 60,000, right? So we don't want to do any worse than our base case. If we purchase worse than our base case, then we haven't accomplished anything, right? And so then we see that these other values here are reductions from that for off-site electric purchases. Okay, so go back to our criteria tree, and now this once again shows our score for each one of these individually. Boom, boom. And all we want to do right now is just kind of look at the overall how it all ranked out here in the. So when we look at all of this taken together, investment split between investment and total equivalent, energy between site and source, and electricity site, trying to minimize our purchased electricity on site. And notice the best score, of course, is that base case with solar, right? So let's just look at the sensitivity of that real quick. And we see that best case with solar, the purple model, is running right through here in the middle, right? And our best case with cogen is running right here. So we're actually producing more electricity with the cogen than we are with our solar production. Okay, and it pretty much, you can see those guys coming here and coming together. And when they change is when you're weighting off of between the electricity site and energy and investment. But these guys run pretty close together. So that's pretty good when you get them by this time. If you get all these in here and you see the sensitivities running pretty, there's a slope here, and it just kind of depends on where you want to weight each of these. So if you took energy security up here all the way 100%, then the one that we had the largest reduction on was this best case, and this best case was solar, right? And then if we went to the other end of the spectrum, our best case with cogen, we took electricity site out as well to 0. But leaving it the way it is, we see that we have, this is the rank order of this particular model. So we're going to close this and save it. And then we're going to compare all of these models together just to get an idea of how all these guys compare together. And this gives us even a higher level look at what we've done. And so, like I said, one of the first things that I look at is this base case sitting here as the worst thing to do. That's one thing. The baseline is still sitting here, so because of our criteria, we're trying to minimize stuff. Since we have less square footage and less dollars invested, it kind of sits at the top. But once again, this isn't what we're comparing against. It's just here's a reference point. This is what we're comparing against, and we're really trying to decide between these 5 models, business as usual, and or one of these other cases here. And so now we look at the average scores between these, and this is really darn close, running right through here. So we see that our best case, so if we look at our best case, it runs from 2nd place down to 4th place in the 4th model. Okay, so just if you invest and you reduce your energy consumption at your buildings, and with that investment, you do get a reduction, and it scores with your dollars and all your energy reductions, along with your electricity purchase off-site. The way it's all weighted and the way it's all scored, it comes out as currently as the highest average rank, with a close second. I mean, we're talking, this is in the noise here. I mean, all of these really are darn close. And you could either go deeper into the weeds, you could look at other options. In other words, you could go back and say your best case was solar. You could look at a 40% source reduction to see how that looked against that. So this is where I think it gets really interesting, because you get to look at this macro view of it, and there's a ton of work and data that got us to this point. And here people will ask obvious questions. What happens if I did? What happens if I did something? And that you can either go back and change those models, change those assumptions, and at this point, it would all those numbers would just roll up and rescore in here automatically, right? If you went back and made a slight change, reran either an optimization or a simulation, it'd all roll in here. If you went in and changed investments, through this, well, what happens if my solar was more expensive, my cogen was cheaper, my cogen's more expensive, my solar's cheaper? You change those numbers, and it all rolls up here and gets rescored. So this is where all that work and effort pays off, and you actually are able to come in and talk about data, and look at your answers objectively with data, and you can change some weighting still. I mean, one of the things that if we looked at that model 4, let's go back real quick and let's look at that. If we want to make it in line with some of the others, if we went here and we changed, at this we got this third weighting, right? But that's not how we started. We started with a 60-40 weight here, and let's see if we can somehow reproduce that. So if we had 60-40 on 2/3, calculator. That is close to that. 2/3. It's gonna always equal that. It's not making okay, and then point. Okay, so if we take that 60-40 split on this piece of it, and we could change these weights. Let's just look at this, and let's go back to criteria tree. Let's close this model. Let's definitely save it. And let's look at those. Are all sitting in calculate. Now let's go ahead and look at this. And now we can see what, the changes there. So the best case is 2 and 4. The best case with cogen was 2 and then 5. So these all became a virtual tie. Remember, this was 3-0, 3-2-5, 3-5. This became a virtual tie right here in the middle. And so you'd either have some other criteria, some other conditions, whatever else to for this tiebreaker. What it says to me is you need to go to the base case, and then you need to kind of define on what type of technologies that you're comfortable with and where you want to go and how you want to go with that to meet that. But this is the essence of what the MCDA model can do for you, and I think there's a lot of power sitting at this level, at this end, and it helps to add data to people who are just instead of bias, because there's tons and tons of bias out there as people look at these things, and then this adds data to hopefully lead people in a way of moving away from their bias on certain things and providing some analytics behind this. So that's all I had planned on covering for this, and I think that for my objective, of course, was to help you understand what these models did, how they're generated, how they and how you can take these pieces, but also to help understand that some of these you need to look at. I thought it was interesting, looking at the total investment versus the total unannualized and seeing that, and then of course I knew that adding the site and source energy would make changes, and then trying to come up with part of a way to quantify energy security, and so that was kind of my look through all this thing just to see what would happen.